So for our last lesson of the year, we're going to talk about how to find the derivative when we have a composition of functions. So you'll notice in this function 3x plus 2x squared all raised to the fifth that the inner function 3x plus 2x squared is within the entire fifth power function. So in other words, g of x is inside the f of x, where the g of x is the x cubed plus 2x squared, g of x is x to the fifth. So when we take this composition f of g of x, we get this function back. Whenever we have composition of functions, we're going to use something called the chain rule. So what is the chain rule? The chain rule states that if you've got a composition, then the derivative of that composition is actually the composition of the derivative of the outside function multiplied by the derivative of the inside function. I like doing it this way. I like thinking about it as letting the inner function be some u value and let y equal f of u. Then these two statements will be equivalent, that the derivative with respect to x is equal to the derivative of the u function, which is that inner function, in terms of y times the derivative of that u function in terms of x. And then you'll notice these du's go away and I'm left with dy dx. Let's apply this so we can see what's happening. So here's our initial function. We have our inside function and our outside function. So we're going to say that w of x is equal to u to the fifth power, where u is equal to 3x plus 2x squared. So now, if I take the derivative of w with respect to u, so I'm finding the derivative of this term in terms of u, I get 5u to the fourth. Now if I take du dx, in other words, the derivative of u with respect to the x variable, I get 3 plus 4x. And then if I take dw du, multiply it by du dx, I'm going to get the derivative of w in terms of x. So these will go. So let's multiply these together. I get 5u to the fourth multiplied by 3 plus 4x. Now, I know the u value is 3x plus 2x squared, so I'm going to make that substitution. And I get 5 times quantity of 3x plus 2x squared, all to the fourth, multiplied by 3 plus 4x. And I can clean this up a little bit. Multiply the 5 times this term, I get 15 plus 20x, all multiplied by quantity of 3x plus 2x squared raised to the fourth. And that, once again, is w prime of x. Let's do some more. So in this case, I have another function within a function. 5x to the fourth plus 7 is within a square root function. I'll rewrite it to look like 5x to the fourth plus 7, all within the 1/2 power. So in this case, w of u is equal to u to the 1/2, u of x is equal to 5x to the fourth plus 7. Derivative of w with respect to u is half u to the negative half derivative of u with respect to x is equal to 20x cubed. So once again, dw du times du dx is equal to dw dx, or 1/2 u to the negative 1/2 times 20x cubed. I'm going to go ahead and clean that up just a little bit. Half times 20 gives me 10x cubed over the square root of u. And now we'll make our substitution for u. We knew that u was equal to 5x to the fourth plus 7. So dw dx, or w prime of x, is equal to 10x cubed over square root of 5x to the fourth plus 7. We're going to leave it like that rather than rationalize. This next problem is somewhat similar, but a little bit different. I'm more of a fan of making my f and g function kind of all in the numerator rather than the denominator, because this kind of looks like a quotient rule, and I would rather not do two methods of finding the derivative instead of one. So this is negative 7 over 4 multiplied by 2x minus 3 to the negative third power. So in this case, w of u is equal to negative 7 over 4 u to the negative 3 power, while u of x is simply 2x minus 3. So if I want to take dw du, I get 21 over 4 u to the negative fourth, while du dx is equal to 2. So dw du times du dx, which is dw dx, or w prime of x, is equal to 21 I'm going to go over 4 u to the fourth times 2. Once again, we can clean this up quite a bit. Make a substitution and reduce 21, or reduce 2 and 4. So I have 21 in my numerator, 2 and 4 reduced to a 2 in the denominator. U is 2x minus 3, and that's all raised to the fourth. And that is w prime. So here's another situation where we have a function within a function, although it appears that there's a function within a function within a function, but we can rewrite this so it's just one function within a second function. This is quantity of x squared minus 1. If we remember our rules of exponents, it's all to the 3/5 power. So wu is equal to u to the 3/5. So therefore, u of x equals x squared minus 1. dw du is equal to 3/5 u to the negative 2/5, and du dx equals 2x. So dw du times du dx equals dw dx, or w prime of x, which is 3 over 5 u to the 2/5 multiplied by 2x. No big reductions go on, so we'll just have to go ahead and simplify. Let's go ahead and do that. W prime of x. That's 6x in my numerator. Bottom on the denominator, I have a 5. We convert that fraction back to radical form. So I have the 5th root of u, which is a quantity of x squared minus 1 squared. And that'll do it. So there's the introduction to the chain rule. Write out your lesson summary, and we'll chat more tomorrow.